So LeetCode 1658, minimum operations to reduce x to 0. In this problem, you're given an array of numbers and an integer x, and in one operation you can remove the leftmost or the rightmost element from the array and subtract its value from x. And then you need to return the minimum number of operations that you need to reduce x to 0. And if it is impossible, then you just return -1. So in this example here, you can just remove these two rightmost elements, and so the answer is 2. So what we are going to do is we're going to calculate the rolling sum of all of the elements from the left, and we're going to store the sum up to a certain index in a map. So for example, the sum up to 4 here is 1, 2, 6. So we're going to store in our map that if you want a total of 6, then you're going to need to remove 3 elements. And what that is going to allow us to do is it's going to allow us to then pop the elements from the right. So for example, I'm going to pop 3, and I'm going to say, okay, now I need, now my x is 2, and so how many elements do I need to remove from the left to remove a total of 2? And that map is going to tell me, I'm going to look it up in my map, and that's going to tell me you need to remove 2 elements. And I'm going to think, okay, so if I remove 3, so 1 element from the right and 2 elements from the left, then I get x equal to 0. So that's one possible solution. And then I go further and I say, I pop 2, and so then I've popped from the right 5, so x is now 0, and I ask how many elements do I need to remove from the left so that the total removed is 0, and the answer is 0. So I update my result with 2, which is the numbers that I've popped from the right, and plus 0, which is the number of elements that I had to pop from the left. And so that gives me my final answer. Okay, so let's implement that. So I'm going to have my result, which starts at +infinity, and I'm going to have my index map, and this is what tells me how many elements I need to remove to get a certain sum from the left. So to get a sum of 0, I need to remove 0 elements from the left, right? That's just like your base case. Then I'm going to do the rolling sum. So I start with a sum of 0, and then I loop through all of the numbers in the array, and I add to the sum the current number, and then I memorize in the map that if I want a total removal of sum, then I need to remove i+1 elements. So for example, when sum is equal to 1, the index is 0, but actually you need to remove 1 element. So that's why we do i+1 here. Okay, so at the end of this block of code, index is going to store, like if you look up in index, you look up something like 6, you're going to get the amount of elements that you need to remove from the left so that the total removal equals to 6, right? Or you're going to get undefined if that is impossible. Perfect. So now what we can do is we can set up another loop where we pop elements from the right. So we keep track of how many we have popped, and we keep track of the total sum of the elements that we have popped from the right. And then while we haven't popped all of the elements, so while there are still numbers in the array, we update our result with a potential solution. So we check if the current how many popped and total popped are possibly a solution. And if it is, then we update our result, which starts at +infinity. And then no matter what, we pop another element, right? Okay, and now at the end of this while loop, we check if the result is still +infinity, meaning that we never had a amount of popping from the right that leads us to having x equal to 0. And so then you just need to return -1 because of the problem statement. Otherwise, you just return the result. So now we need to implement this update result function and this pop right function. So the update result should look at how many elements we've popped from the right, and it should look up in the index table or map if we have some number of elements removal from the left that makes so that x goes to 0. And if so, then it should update the result. And pop right should just pop 1 element from the right of the nums array and update these 2 values, right? Okay, so we're going to implement those 2 down here. So to update the result, you check how many more you should remove to have x going to 0. So the total popped is stored here. So we have x minus tot popped. So that's the leftover that we still need to remove from the array, possibly from the left elements, so that x goes to 0. And now we check in our map, which we prepared previously, we check, is there any amount of left elements that I can remove from the array so that I can cover this leftover from x. So this is the amount of left removals that are needed to get this leftover removed again from x. And then we need to check if this is undefined, because if that's undefined, then it means that it is impossible. And we also need to check if the amount of left removals needed is greater than the number's length. If so, then we can't do that. So this is one of the conditions that tells us that we cannot do that if it is undefined. So for example, it tells us I need a leftover of like 9,000 and you don't have 9,000, and so that's undefined. Or the other condition is you need to remove more elements than there are in the array, because maybe you've popped some already and like the original number's length was like 10, but then you've already popped 5 and you need 6 removals from the left, right? So that's why you need to return, and you can't update the result if either one of these two conditions is met. And now you need to do the actual, now that we got this out of the way, we need to do the actual update of the result. So you update the result with the minimum between himself or the amount of removals that you need from the left plus the amount of removals that you need from the right. Okay? And now you just need to implement the pop right function, which is pretty simple. You just pop one element from the nums array and you sum its value to the total popped and you increment how many popped by 1. So yeah, that's literally it. So I'm going to submit the solution to show you that it works. And the time complexity here is O of n, because at most you go through all of the elements like twice. And the space complexity is O of n, because you need a map, and that could possibly store up to O of n space. So that's it for me today. Thank you for watching, and bye.